My name is Sergio Bermudez. I'm a senior researcher at M-ITI and I'm an associate professor at the University of Madeira. I've been around M-ITI for 8 years, and what I'm doing here is we research interactive technologies and we apply them to the health domain. And we have several projects going on here all around this, mostly on active aging, dementia and stroke rehabilitation. All of the projects we are involved in have as a common ground the idea of improving the quality of life of those that have special needs. And we have as target 3 populations. One of them is aging, the elderly population. We're developing technologies to keep them fit, to keep them independent. We do that through exergames. That's games that promote physical activity. A second project that we have relates to stroke rehabilitation. After a stroke, many competences, both motor and cognitive, are affected and are lost. And there's need for a rehabilitation process. And the tools that we have are not necessarily optimal. And what we're trying to do is to develop technologies that can help us further with the rehabilitation process. And we do that through virtual reality, applying it to the rehabilitation of motor deficits and also to the rehabilitation of cognitive deficits.
CAVE was a project that we started here at the NeuroRehabLab because we wanted an immersive virtual reality system. But caves, although they exist for some years, they remain quite expensive. So we had to do it ourselves. For this, we built this system with these walls and projectors, and then we had to program the software for it. What this allows us is to have a very cheap system compared to the traditional systems. It costed around 5,000 euros maximum. Most of the price was for the projectors, not software or expensive tracking systems. And this allows us to have a very immersive system that avoids cyber sickness, and also beyond the traditional caves allows us to interact with the whole body with the virtual elements. And the user doesn't need to wear anything. So that's some of the advantages of this system compared to the traditional ones.
So we scaled down this type of system setup for more simplistic approach in which we are using just a projector that is basically projecting games on a floor. And we use this in order to create exercise video games, exergames, that can be used to promote physical fitness in older adults. So we develop, we design several types of different games that are targeting different functionalities in the fitness domain, such as cardiorespiratory, musculoskeletal, and balance. So we are actually applying this type of exergames in a training program in a senior local gymnasium here in Funchal. In a sense, we are using body tracking technology, and they are playing in this floor projection. They have to move, they have to carry out different lateral movements, they have to, for instance, row in a virtual boat. They are basically immersed in a Portuguese virtual tour that covers different traditional activities here in Portugal. So they are normally playing this set of different games, kind of like mini games, but at the same time they are making exercise. And we are trying to fit our extra games to what is recommended for this specific senior population.
The goal of my project is to activate mechanisms, psychological mechanisms that might be impaired in dementia through the use of specific musical stimuli that target these mechanisms. We know that in healthy patients we can arouse different emotions targeting different psychological mechanisms that are activated in different areas in the brain, but we don't know yet how do dementia patients respond emotionally to music, and we know that the emotion is really important for rehabilitation. Well, there are two ways to measure. There's not a completely direct way. We can ask participants, so have their self-report about how they feel, and then we can use psychophysiological measures to measure how excited participants get by measuring the skin conductance of the skin, and also by measuring the two muscles that are involved in when you feel emotional, the corrugator muscle that would show negative emotions, and the zygomaticus muscle that would show when participants feel more positive emotions. So by understanding how these stimuli target emotions, we can use this to stimulate emotions that are not frequent anymore in dementia due to the illness itself. So as the illness progresses, we know that some mechanisms become impaired. So through this stimulation, we can build better stimuli for intervention in rehabilitation with these patients in the future.
So what we are looking at here is a virtual reality system designed for the rehabilitation of cognitive function after stroke. It's very common after stroke to have cognitive deficits of different kind: attention, memory, perception, executive functions, etc. One of the problems that we have is that patients, while they are at the hospital, they cannot train those competences effectively because they are in bed. They don't have the physical autonomy to perform those actions. So there is a regression in those cognitive competences. What we have developed here is a simulation of a city, which is an ecologically valid environment because it reproduces environments that are similar to the daily life. And there we have reproduced a number of activities that patients of the age, that's generally elderly, usually have to go. Like, for instance, going to the pharmacy. Then they have to select the medicines they need to buy. They also have a cash machine. They usually withdraw money or they pay bills in the cash machine. They have shops in which they have to buy appropriate clothing, for instance, for the season of the year. And the basic idea is, instead of training cognitive skills through paper and pencil tasks, which are very different from the challenge that you will have when you go to the supermarket, we train it actually going to a virtual supermarket. So that makes that the transfer of the skills that have been learned in such a technology, in virtual reality systems, to the actual reality, it's much shorter, and therefore the generalization of the learning of the skill is higher. We have run some studies here with the local hospital, the CESARAM, and we have seen that this type of rehabilitation is actually more effective than conventional rehabilitation without this type of technology. So the results are quite encouraging towards using virtual reality systems for rehabilitation. One of the problems that we have when we are developing technology for patients that have suffered a stroke is that they will most likely have motor deficits that will make very difficult for them to interact with computers. Second, average, they will be elderly. That means they probably haven't used computers that much and they are not very used to this type of technologies. And third, the cognitive skills may be affected by the stroke. So in this context, we cannot just use joysticks, keyboards, or mice as the interface with a computer. So we have a challenge here of human-computer interaction. How do we make patients interact effectively with a computer when they are motor impaired, they may be cognitive impaired, and actually they don't know computers very much. So what you're looking at here is an interface that has a marker that's being tracked by a camera. And as opposed to have a mouse that has a button, it's small, it has a cable, and it may be a little bit complicated for elderly. This interface is very simple. It has a large base that stabilizes the hand, the movement, so patients do have the position corrected, that's important. It's resting on the table surface, so they don't have to move it on the air. They just drag this up and down, and therefore it facilitates movement, and then it's calibrated to the range of movement of the patient. So if they can move a lot, the transfer and the gains between the movements in the physical device to the virtual environment are large. If they cannot move very much, we can change the gains so the small physical movements are represented as large movements in the virtual space.